probably wondering what just happened to me. Well, in this video, we're going to be talking about the laws of gases and the men who are responsible for making these laws. Walk with me. Oh, hey, I didn't see you there. I was just reading up about the laws of gases and how they affect the world around us. You see, the thing with gases is that there are many different units we can use to describe them, such as Pascal, kilopascal, pounds per square inch, or PSI, atmosphere, or as I like to call it, ATM, bar, which is just labeled as B, millibar, inches of mercury, torr, and millimeters of mercury. You see, now all of these units are going to come in handy later whenever we're actually working with gases. You know what? Let me show you something. Now there was a man in chemistry. His name was Mr. Boyle. And he made something that I'm pretty sure nobody watching this video has ever done. He made a law that all chemists follow. That law is called Boyle's law. Now it's a law stating that the pressure of a given mass of an ideal gas is inversely proportional to its volume at a constant temperature. So when I say that, that means that this is an inverse formula. Now, you might be asking yourself, what does Boyle's law look like? Well, here's a little graphic for you. Now this is a chart that explains what Boyle's law is. Alright, get out of here. And, you know, obviously with all chemistry things, there's a formula to it. Which formula is that, you ask? That one right there. The pressure 1 times the volume 1 equals pressure 2 times volume 2. Alright, get out of here, you little rascal. Now you might be asking yourself, Daniel, how can I use Boyle's law in the real world, in the now? Well, it's something that I'm pretty sure all of you do every single day. Boil water to room temperature. Alright, stop. Hey gang, I'm in my car now. Anyways, here's a problem I think you could use just to help you figure out what Boyle's law is. Now, let's say that I have 28 units of pressure, right? And let's also say that I have 1 unit of volume. Now, 28 times 1, as we all know, is 28. Now, let's say I had another thing that was 1 unit of pressure and 2 units, 1 unit of volume. Now, 28 times 1, as we all know, is 28. Ipso facto, 28 equals 28. That's Boyle's law. I am getting pulled over for talking about myself. Now, as you can see, this is a pot of very cold water. Don't believe me? Brr! Now, just watch what happens when I use a little bit of Boyle's law. Whoa! Woo. A little too much Boyle's law there, but hey, at least one thing in this room is boiling.
Transmitted at the request of the United States Office of Civil Defense. The North American Aerospace Defense Command detected 3 ICBMs launched from North Korea. The first missile is expected to reach the Los Angeles, California area within 2 hours. The second missile is expected to reach Chicago, Illinois in 3 hours.
What happened to Jeopardy?
The third missile is expected to reach New York City,
Hey guys,
New York
what's going on?
in 3.5 hours.
You know what, since you guys are here, I might as well explain Dalton's law of partial particles. There's something good on TV anyways.
Anyone, which is most of the United States.
Now, let's see here. Dalton's law of partial particles is defined as states that in mixtures of non-reacting gases, the total pressure exerted is equal to the sum of the partial pressures of the individual gases. Now, Dalton's law is related to ideal gas law. So in a way, they're kind of like cousins-ish. Anyway, now there is a formula for Dalton's law of partial particles, and it goes a little something like this. PT equals P1 plus P2 plus P3, and so on and so forth, until you get all of the partial particles you add up, and then that equals the total particles. Alright guys, get out of here.
Alright. Have you ever wanted to convert Celsius to Kelvin? Well, I am here to teach you how. Here are the simple rules. You take the degrees in Celsius, then you add to 73.15. Then you write a K next to the number. That's how you convert Celsius to Kelvin. Everybody now, Celsius to Kelvin. Alright.
To explain ideal gas law, I figured I'd kind of, lower myself. I'd get down to your guys' level. And what better way than with a rock and drum solo? Anyway, so this is a drumstick, right? Now, with this drumstick, I'm going to hit the snare, alright? So, now, except this isn't really a drumstick. This is 600 grams of oxygen in a container that needs to be kept at a pressure of 1 atm, and a temperature of 125 degrees Fahrenheit. Now, the ideal gas law, that would help me, an engineer, find out exactly what kind of volume this container needs to be stored in. Did that answer your question? Now we're going to talk about ideal gas law. Now you might be wondering to yourself, we have Boyle's law already, what do we need an ideal gas for? Because Boyle's law, if you think about it, is pretty much identical, except it's not. Now you see the ideal gas law, it's also called the general gas equation. It's the equation of a state of a hypothetical idea gas. It is a good approximation of the behavior of many gases under many conditions, although it has several limitations, which we really can't get into now. Now you might be asking yourself, is there really another formula for this equation? Yes, it is. It's right here. Go away, buddy. Hey, King. I had a little trouble getting out of bed this morning. But since I have you here, I'm going to go ahead and explain STPs. Now, STP stands for standard temperature and standard pressure. Now, when I say standard, I mean that there's a number for them. What number is that, you may ask? Well, the standard temperature for gases is more commonly 0 degrees Celsius or 32 degrees Fahrenheit, but when we're working with gases, we always use Kelvin, so that's going to be 273 Kelvin as the standard gas. And the standard pressure is going to be 1 atm of pressure, or 1 atmosphere of pressure. And so it looks like our journey with gas laws and the introduction to gas laws has come to an end. Thank you for watching. I hope you have a great day.